Okay, imagine this. You just finished installing a program on Windows, maybe a game, maybe some software for work, and right before you are about to use it, Windows pop up with that message. Restart now or restart later. And you are like, why? I just installed something. Why do I need to restart the whole machine? So you restart it. And then Windows hit you with an update. Same thing again, restart required. So why does Windows keep asking you to restart? And more importantly, why does Linux almost never do that? So let's talk about what actually happening when you install something on Windows. When you run a program, any program, Windows loads a bunch of files onto memory to make it work. These files are called DLLs, Dynamic Link Libraries. Think of them like a shared building blocks. Your program say, I need this block in this one and that one, and Windows load them onto the memory so your program can use them. Now here is where it gets interesting. While your program is using one of the DLLs, Windows put a file lock on it. Like literally, it marks that file as in use, don't touch. That makes sense, right? You don't want something modifying a file while a program is actively running with it. The problem is when you install a new software or when Windows pushes an update, sometimes it needs to replace one of those DLLs with a newer version, but it can't because the file is locked. Some other process is already holding a handle to it, basically a live connection between the program and that file. So what does Windows do? It writes the replacement instructions onto something called the registry, specifically a key called PendingFileRenameOperations. Fancy name, simple idea. It's basically a to-do list. It says, okay, I can swap this file right now, but next time the system boots, before anything else starts running, do the swap. And when does that happen? When you restart, no running process means no file locks mean no open handles. Windows can finally go through that list and replace everything it needs to. That's the restart. It's not random, it is Windows waiting for the one moment where nothing is running and can safely do the job. To see this in action, let's use VLC. Let's open VLC and while it's running, go to its installation folder. VLC is using a DLL called libvlc.dll. If you try to delete it or replace it while the program is still open, Windows will usually stop you and say the file is being used by another program. In this case, the fix is easy. Just close VLC and now the file is no longer in use. But with the system files, drivers or servers running in the background, it's not always that simple. You can't just close the thing using the file, so instead Windows schedule the change for the next restart. Let's actually schedule an operation for the next restart. We can do that with sysintel's tool called MoveFile. It lets us queue a file operation that Windows will carry out during the next boot. For example, we can tell Windows to move a file from downloads to desktop the next time the system restarts. Now let's go look at the to-do list. Press Windows plus R, type regedit and hit enter, then navigate to this path. Look for a value called PendingFileRenameOperation. If it is there, that means Windows has something queued up for the next restart. And just like that, you can actually see the operation sitting there waiting for boot time. Now let's look at a real example, Windows updating itself. We open the registry and check pending file rename operations, and sure enough there are already some operations queued up, updates for things like Edge and other system components. So we start the machine. After the reboot we check the registry again. Some of the earlier tasks are gone, which means they were completed during startup. But now we notice something interesting. There are new operations in the queue, including more DLL replacements. In other words, the first restart cleared the first batch, but finishing those updates trigger the next batch. So we start one more time. And now, when we go back to check pending file rename operations, it's gone. That means there is nothing left waiting for boot time. The queue is empty and all the pending file operations has been resolved. Windows basically wrote itself a note. Hey, next time we boot, swap this file, and sometimes one note leads to another. That's why one restart can turn into two. Now, to be fair, locked DLLs are not the only reason Windows asks for a restart. Sometimes it is not just replacing a file. Sometimes Windows is updating something deeper, a driver, a kernel component, a system service, or part of the operating system that's too critical to swap safely while everything is still running. And sometimes the update is not really complete until Windows starts again and rebuild part of its slate. reloading drivers, reinitialization, services, applying boot time changes, finishing configuration steps that can only happen during startup. So yes, file logs are a big part of the story, but the bigger idea is this. A restart is Windows' clean slate. It is the one moment where the system can stop everything, load the new versions, initialize them in the right order, and come back up in the consistent state. But now, imagine the same problem on a server. Not just any server, a domain controller, the machine handling authentication, group policies, user logins in many Windows environments. That's a critical piece of infrastructure. Now, Windows Update shows up, security patch critical, and it says restart required. So, what does the IT team do? They can't just click restart now in the middle of the day. On a server, a reboot has to be planned because user can be affected. So instead, they schedule a maintenance window, usually late at night or on the weekend. Warn everything in advance and do it then. This is not a one-time problem. Microsoft releases security update on the second Tuesday of every month. IT people call it Patch Tuesday, so every month team have to plan around restart. Now scale that up. Not one server, dozens. Domain controllers, each one has to be restarted carefully, in the right order, without breaking the service that depend on each other. What looks like a simple reboot on the surface turned into a real operation. That's why serious environments breed redundancy. Two servers doing the same job, so one can stay online while the other restarts. That is real infrastructure, real planning, and real cost, all partly because restarts are disruptive. And here is something most people never see on a home PC. When you manually shut down or restart a Windows server, it may stop and ask you, why are you doing this? Instead of shutting down immediately, Windows gives you a list of reasons to choose from. Was this planned or unplanned? Was this for a security update, a hardware issue, or some other system change? If the reason didn't specify, like shutting doing from power button, a tool called the Shutdown event tracker asks you for the reason of shutting down. As you can see, it asks you for the reason, whether the shutdown was planned, and even lets you add a comment so the action is documented properly, and that gets logged. In Event Viewer, you can actually see it recorded as Event ID 1076, along with the reason for the shutdown. That tells you something important. On a server, a restart is not casual. It is an event. It has consequences. Someone has to own it. And Microsoft knows this is a real problem. That's why new versions of Windows Server like 2025 or some versions of Windows 11 introduce things like hot patching, applying many security fixes without needing a restart. Sound familiar? This basically Microsoft moving toward a world Linux has lived in for a long time, which brings us to Linux. Okay, so now let's talk about Linux, and I want to start by cleaning something, because there is a misconception a lot of people have. People say Linux never needs to restart, and that's not fully true. Linux restarts too. If you update the kernel, the core of the operating system, you need to restart. If you change hardware, if you update firmware, you restart. Linux is not magic. But here is the key difference. Linux needs to restart way less often, and specifically installing software or applying most updates almost never requires a restart, and the reason why comes down to one fundamental difference in how Linux handles files. On Windows, when a program opens a DLL, it grabs that file by its name and lock it. The name and the file are basically the same thing, so as long as the program is running, that name is taken. Nobody else can touch it. Linux think about file completely differently. In Linux, every file has two things, a name that you see and an inode underneath. The inode is the actual file, it is the data, it is the content, but the name is just a label pointing to it. Think of it like a hotel room. The room number on the door is the file name. The actual room with everything in it is the inode. Now, when a running program opens a library file on Linux, it grabs a reference to the inode, the actual room, not the name on the door. So what happens when an update comes in? Needs to replace that file. Linux just put a brand new inode in place and point the name to it. The old inode is still there, still running. The program using it has no idea anything changed. It is like changing the room number on the door while the guest is still sleeping inside. They wake up, everything is fine, they never noticed. And for the new programs that start after the update, they follow the name, find the new inode, and get the updated version immediately. Old programs keep running with the old version until they naturally caused. To let the program use the new version, a restart of the program is enough, just for exceptional cases where a restart of the system is required to use the latest update versions. Okay, let me show you something that looks weird at first but actually explains a very powerful concept in Linux. We are going to prove that a program can keep running even after its file is completely deleted. So let's try it. First, I'm going to copy a simple program, the sleep command, into /tmp. Now I run it. This just tells the program to run for 5 minutes in the background. So right now we have a running process using that file. Let's confirm that I'll use elseof pipe grep mysleep. Elseof means list open files. It shows which files are currently being used by processes. And here it is. You can see /tmp/mysleep is being used. Now here's where it gets interesting. I'm going to delete the file. Done. The file is gone. If I check /tmp, it is not there anymore, but the process is still running. Let's check it again. Elseof pipe grep myself. Now look at this. This is the important part. The file is deleted from the file system, but the process is still holding it in memory. Linux didn't kill the program. It didn't cache anything. This is exactly what happens when a Linux updates libraries. The system replaces the file on disk, but running programs keep using the old versions in memory. That's why you don't get forced to restart like Windows. Programs only switch to the new version when they restart naturally. So this layer demo deleting a running file is actually showing you how Linux handles updates under the hood. And once you understand this, you start to see why Linux systems can stay up for a month without interruption. So next time Windows asks you to restart, you know exactly why. It is not being difficult, it's just waiting for everything to stop so it can finally do the swap. Linux just never had that problem to begin with. If this video made something clicks for you, drop a like, it generally helps the channel. Until next time, bye bye.